Hey guys, welcome back to my YouTube channel, and what I have for you today is part 2 of my Wear OS timer application on Android Studio. So if you guys haven't checked out the first part, go back and check that out. And before we start, I'd appreciate it if you guys would like and subscribe, and let's get into it. Now we're looking at the file called timerstore.kt. This file is responsible for saving and loading the timer's state, even if the app or the watch process is closed. It uses Android's DataStore to persist simple values like how much time is left, the total duration, and whether the timer is running. At the very top, there's a line that creates a preferences data store. This instance is tied to the application's context. You can think of DataStore as the modern replacement for shared preferences, and its type safe, works with coroutines, and avoids blocking the main thread. Next, we have an object called keys. This defines the 3 preference keys we'll store in the DataStore. One for remaining milliseconds, one for total milliseconds, and one for running. They're created using helper functions like long preference key and boolean preference key. Then we have the TimerStore class. The class itself takes context in its constructor, in which inside there are 3 public flows: remaining milliseconds, total milliseconds, and the running flag. Each one reads from the data store using context DataStore data map, which transforms stored preferences into actual Kotlin values. If a value hasn't been saved yet, each flow will provide a default. For example, remaining milliseconds and total milliseconds default to 25, and running defaults to false. That means that even when you freshly install it, the app still has to show something. At the bottom, there's a suspend function called update. This function edits the data store and updates any of the 3 values that you pass in it. Each parameter is optional, so that you can update just one piece of data without having to touch the others. So that's it for this file. Now we're going to go look at the next one, which is timer-tileservice.kt. Now the point of this file is that it controls the Wear OS tile, the small glanceable view that appears when you swap left or right from the watch face. The tile shows the current countdown time even if the app itself isn't open, and updates automatically as the timer runs. The class TileService, which is part of the Wear Tiles API, handles 3 main things: creating the layout, supplying resources like images or colors, and responding to tile updates requested by the system. Let's start with onTileRequest. This function gets called whenever the watch needs to draw or refresh the tile. Here, the system asks for a tile, and we have to return one wrapped in a listenable future. Here we use callBackToTheFutureAdapter.getFuture to build that response asynchronously. Inside we call buildLayout to get the actual tile layout. That's the function we're going to look at in a second. Then we wrap the layout in a few standard Wear OS structures: a layout, then a timeline entry, then a timeline. Finally, we create a tile object with a resource version of 1 and hand it back to the system, which is what actually appears on the watch. The string on the end, timer-tileService onTileRequest, is just a debugging tag, so the system can identify this future in logs if needed. Next, we have onResourcesRequest. This is a simpler callback where the system asks for any resources the tile might need, things like images, fonts, or icons. In our case, the tile is pure text on a solid background, so we just return an empty resources object with version 1. That tells Wear OS that nothing special is required. Now here's where the visual part happens. The build layout function, this builds the actual tile layout that the users will see. First, we create a TimerStore instance using the context, and then read the most recent saved values for remaining time and total time. Now notice that we use run blocking here. That's because the tile APIs are not suspend functions. So we briefly block the current thread just long enough to pull those data values from the data store. After that, we calculate the minutes and seconds from the remaining milliseconds and format them into 2-digit display, for example 4 minutes and 59 seconds using a string format. Next, we create a dark background modifier. It uses a solid black color applied through a background dot builder. This gives the tile a clean, minimalist look and ensures good visibility on OLED screens. Then we create a simple text element showing the formatted line. There's nothing fancy going on here. It's just plain text for maximum capability. Some versions of the tile's APIs have differences in how alignment or gravity works. So we keep it simple and let the box container handles centering by default. Finally, we build a box that applies the dark background modifier and adds the text inside. That box becomes the root element of the tile layout. When the layout is complete, build layout returns it back to onTileRequest, which packages it into the final tile object that the watch displays. At the bottom, we define two constants inside a companion object, action toggle and action reset. These act as placeholders for future features. So that sums up this file, and next we're going to look at the actionReceiver.kt file. This file is a simple but important piece. It lets the Wear OS tile actually control the timer without opening the full app. This class extends BroadcastReceiver, which is an Android component used to react to system-wide or app-wide broadcast messages. When the tile sends an intent, for example, to start, pause, or reset, this receiver wakes up, runs a little bit of code, and then immediately shuts down. Inside the onReceive function, we first create a timer store using the provided context, so we can read and write the same data that the view model and the tile use. Then we call run blocking. That's a quick way to run suspend functions inside this non-suspend environment. We use it here because DataStore operations are suspend functions. Inside the when block, we check the intent's action to see what the tile requested. If the action is action toggle, we read the current running state from the store using store.running.first. And then we flip it. If it was true, we make it false, and if it was false, we make it true. That's what pauses or starts the timer from the tile. Now if the action is action reset, we grab the total duration from the store, then we call store.update to set remaining back to that total and mark running as false. That resets the timer completely. Now that we have gone through the entire code, let's now run and test the app. So here you see that the app is now running, and you can scroll up and down. So if we click start, you see we have 1 minute on the timer, and as the minute starts to count down, the ring here starts to fill up. And if we press pause, it pauses, reset goes back to 1 minute, and here are the chips that are preset for quick access. The two chips that we have are 25 minutes. As you see here, the timer shows at 25. We start it and it counts down. And 5 minutes. So again, start, it begins to count down. The ring starts to fill up. And for the last chip here on the bottom, we got custom. So this will go down to 1 minute all the way up to 120 minutes. So we just do 14 minutes for example. Press OK. There you see the 14. We click start, and the ring will begin to fill up, and the timer will count down. And there you have it. So if you liked this video and this series, I'd really appreciate it if you guys would please like and subscribe. And I really appreciate it, and thank you guys for watching. I'll see you guys in the next one. Thank you.